Okay, welcome people to this live stream. We are talking about chemistry functionality for Wolfram language for the upcoming release. And supposedly this is a final review of some pieces of documentation. So what should I be looking at here?
Great. So atom labels will be a new option for molecule plot and molecule plot 3D. We looked at this briefly, but I hadn't made the documentation yet.
That's very weird. It looks like the isotope.
Right. But it's.
I would put the. Do we really want to put the? I mean, that position is a nice position, I would think. But what do people usually do for these kinds of labels for atoms?
I'm not aware of a normal of a standard.
Okay. Is there an atom label style as well?
Yes, but I don't have the doc page here yet. But you
okay,
could,
but is that a thing that we have, or is it?
Yes. So you could type atom label style goes to red, and it would work.
Okay, but that's bank switching all the atom labels. But what should the default style be?
The default graphic style.
Yes, the default style. Right now you have it just black, which doesn't seem right to me. You see what I'm saying?
Right. Okay. So I will make a note.
Why don't you ask graphic design folk? I would suggest something gray or something else that makes it clear that it isn't, you know, I mean, in this particular case, because the hydrogens are gray, it's kind of, you know, it sort of stands out from that. But I would suggest some kind of default color that is more gray or something, maybe even a background. I don't know, maybe even a little box. I don't know. Maybe that's too precious and not sensible.
But I feel like you have to enforce it to get it. So.
Well, yeah. Okay,
so
fine.
There's little confusion, I feel like.
For what?
For mistaking the meaning of the label as the.
There isn't confusion, you say. Well, there isn't confusion if you were the one who made it.
That's what I'm saying. Yeah. Okay, I see. If you get it from somebody else.
Right.
Okay.
Right. I just think, okay, that's cool what you've got there.
So that's going to be the most common application is labeling stereo centers, but yeah.
Okay. Okay, nice. All right. Okay. Next, bond labels.
And for this first release, the bond labels, you have to manually provide placement to get them not to live on top of the bonds.
What is happening with graphs? How does this work with graphs?
Exactly like this. And so I'm building a layer on top of that. And if I can get that done before this version releases, then I will.
That's fine. Okay. Good. Okay. By the way, don't forget don't forget to link from, you know, bond style to edge, bond label to edge label, et cetera, et cetera, et cetera. I don't know whether you want to link the other way around. I think probably not.
Right.
Probably not. If edge label is kind of, I don't know whether we should link from the graph theory stuff to the chemistry stuff.
I would say no. I would say the other direction, definitely.
Okay. My only reason for saying yes is that I can imagine that somebody says, I just want to change the edge label, thinking, and then they go to the graph theory functionality.
I see what you
mean. And then they get confused.
But few chemists would probably call this an edge.
Yeah, but few graph theory people would think, well, let's just look at something. I don't think it would be bad to just add it at the very end.
Of course.
Yeah.
Now, this is called Vertex Labels, edge labels, and you're calling them singular. Oh, atom labels. Yeah, same thing. All good. Okay, what's next?
Right, so molecule match Q is one that should be fairly quick. And in this case, so we discussed this previously, I would want to, if not necessarily deprecate molecule equivalent Q, but just stop linking to it. So molecule match Q is not var-arg in the way that molecule equivalent Q is. So it doesn't cover all the use cases, which is why I might hesitate to throw up.
Well, so I mean, the case that I can imagine is a union of molecules, same test, arrow, molecule equivalent Q. Right, that's the case that, I mean, that's the, the common case is you just generate a bunch of molecules, maybe algorithmically, and you want to say how many distinct molecules are there here.
Mm-hmm.
What's the best way to do that? Because molecule match Q will be very, very painful to do that with.
Well, I mean, so if that same test is applied on a pairwise basis, then I would do this. I mean, the only thing that molecule equivalent Q does that molecule match Q doesn't is that it takes a whole list, or it takes it's
Varrows,
like
yes.
same Q. It could take multiple variable number of arguments.
Well, so we have isomorphic graph Q,
Mm-hmm.
which I think is pairwise as well.
Mm-hmm.
Yeah.
So I think if that's the case, I'm okay with molecule match Q being the primary thing, because I suspect that our sorting function, well, our same test functions are going to be binarize the way they feed their arguments. So I'm good. Yeah.
So in this case, then the new function doesn't 100% cover the cases of the old one. Should I then mark the old one as deprecated, or just keep it and not knit to it?
I would deprecate it.
Okay.
I think they're all considered experimental now. I would deprecate it before we have more people use it.
Okay.
And just say has been superseded by molecule match Q.
Gotcha.
Include resonance. Is that singular the right form?
So it could either be include resonance structures or include resonance. So resonance as the concept is how we interpret it.
So include isotopes means pay attention to isotopes.
Yes.
And resonance structure means if the benzene bonds or something are on the other foot. Is that what that means? Consider them equivalent?
Yeah. Although in the case of benzene, you normalize it internally to make an aromatic anyway. So, but there are other cases where you have bonds and moving around where resonance will be important. So yeah, but that is essentially the point.
No, give me my chemistry 15 seconds. Say it again. What is the case?
So when so you've got double bonds moving around, basically. The same thing that happens with benzene, but it can happen with non-aromatic structures also.
By aromatic, you just mean it's a hexagonal ring.
Right. Well, so I mean, so if you go to alpha, we have a step-by-step. There are some aromatic structures that are not hexagonal, but there's a set of rules that like if the number of conjugated electrons in a ring meets a particular pattern, then we deem it to be aromatic.
The reason I'm asking all of this is I'm slowly backing into learning chemistry, as you know, as we try and understand this molecular computing stuff. And I'll probably, at the end of that, I will understand one very particular kind of chemistry fairly well, because it'll be the particular, implementation layer we're using. But okay, I don't particularly like include resonance. I think we might want to, who knows what that means? It could be a pendulum. I mean, and Dan on our live stream is suggesting resonance structures.
Yeah, that is clear. Like resonance structures when you're in.
Is it resonant structures or resonant structures?
Resonance.
Resonance structures.
Okay.
So the example is ozone or NO2. NO2 is the famous example for.
I left an example in chat for Stephen to test the resonance equivalence.
Okay.
So for example, it falls in there because you didn't set the resonance.
Well, but also that let's see. So that is something that's in the documentation page that it will work, but it is not hooked
Okay.
up at the moment yet.
So we include resonance will be, I don't
It should be
understand. Why is it saying include? Why isn't it not saying ignore? I mean, isn't this like ignore case? I'm totally unclear. Why is this not saying ignore stereochemistry, ignore isotopes, ignore resonance structure? Isn't that the right way around? I mean, that's what MatchQ is doing, where it says ignore case and so on, right?
That's an interesting point. I was just going off of so we have include hydrogens as an option, and let's see.
No, but that's different. Include hydrogens is an option whether to draw the hydrogens, right?
Yes.
So with resonance structures, though, it let's see, it's not that you're ignoring. So if you want, so in that case that Jan just sent you, the one that that should have returned true when you set.
Wait. Well, I thought oh, it's string match queue. Sorry, string match queue has. Okay, so string match queue has ignore case, and then it has spelling correction. Right, arrow true, which means whether it does spelling correction as part of string matching. So, I mean, I think it would be much clearer if it said ignore, if I'm not mistaken, what it means is ignore stereochemistry. The molecules match even if their stereochemistry is different, correct?
Yes.
Yes.
It should be
So
called
so I think ignore makes sense with isotopes and stereochemistry, and we could, it's harder for me for it to make sense about resonance structure.
Okay, well, explain to me what's going on with resonance structures. What is it actually doing?
So essentially, I mean, what it would work, and I know this is an implementation detail, but if you set that option to true, and the normal, so we would do a normal match, and if the normal match came back false, then we would generate all the resonance structures of mol and do the pattern matching until we get a true. And if we don't,
then I think that's fine. Ignore resonance structures for the match is the right thing, because that's what the fact that you're doing it by enumerating cases is who cares.
Okay.
The issue is it doesn't matter what the resonance structure is. It's still going to match even if the resonance structures are superficially different. So
in that case,
go ahead.
So it would still have the opposite option value as the other two.
Yeah. Wait.
The default option setting.
Yeah, the default option setting is pay attention to stereochemistry, pay attention to isotopes, but don't pay attention to resonance structures.
Yes.
Okay, I'm fine with that.
Okay.
So it would be, so ignore resonance structures. And Dan on our live stream is asking about the operator form of this. I don't see any reason it shouldn't have an operator form. These other things have operator forms. You should document it. Okay, looks good. All right, onward. Next, what's the next function?
I would say chemical formula.
Okay, what is this puppy doing? This one is the one that actually makes, wait a minute, what is this doing?
So it is a symbolic representation of a species with a particular formula.
It's basically not as good as molecule, but this is what you normally see in a text, C6H8 or something.
Okay, but if I want the chemical formula string out of a molecule, what do I do?
Use the formula string subvalue of the molecule.
Okay, and if I say chemical formula of the molecule, will it just make it a bag of atoms?
Yes. So it will. Yeah, it'll drop all of the bond information.
So this will then come back as the same first line as that C8, whatever it is. And if I now say molecule of this.
End of story, yeah. Because there are many possibilities.
And how would I generate all those possibilities?
So So essentially, we have two methods right now for can look up in the knowledge base or look up in Pubchem, and we're looking
Okay,
at
but what function should I use?
so the sub value of the formula entity isomers or Pubchem isomers.
Ugh. Ugh.
So I have another function called isomer list, but I imagine that it would be a WFR instead.
Why isn't it a molecule list? Why isn't there a molecule list or something, or find molecule, you know, something like find molecule of a chemical formula, or find molecules or something for a chemical formula?
Find the isomers would be, I think, more appropriate.
Here's a confusion. Maybe Michael or somebody else can help me with this. You know, I know more about nuclear physics than I do about chemistry, and an isomer is something in nuclear physics. It's an excited state of a nucleus.
Yes.
Yeah, I've heard that also. But in chemistry, it's very oftenly used to describe species with the same formula.
I know that. It just every time I hear it, it confuses me slightly because of that other use. And
find molecule isomers, avoid any confusion.
Yeah, that will avoid any confusion. But I don't understand why it isn't just find. I see. Find molecular. I mean, what it is, it's going to. I understand why you don't like find molecules, because it's
And we give it a second argument, how many, and an option method.
I would think so.
And then in the future, for some classes, we might have an exhaustive enumeration.
Yes.
No, I have a library that can generate them exhaustively, but it's insane how many isomers you can generate from.
Yeah, that's why it's important to have a second argument. Give me 100.
Mm-hmm.
Right. And you might want to sort them a particular way.
That
like,
might
for example,
not be possible.
Well, it might be by its frequency of, okay. I can't, okay. For a person learning elementary chemistry, do they know the term isomer?
Yes.
Yes.
It's introduced fairly early on.
Okay.
Yes.
And so if you prefer that as a function rather than the subvalues.
I think we should do this. I think it's a useful function. Seems like a function one would use all the time. I mean, particularly for more elementary, okay. You know, maybe I'm thinking about my own sort of non-chemistry approach to chemistry, so to speak. But I think, you know, it's like I've got a graph. Tell me, I mean, I could even imagine that this could take a graph and it could do the obvious assumptions about, you know, if it's a 4-valent thing, it's carbon, blah, 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 whatever. Maybe it just, is that completely crazy? Did I give it graphs and it just tells me molecules?
Well, no. So, I mean, we have a graph to molecule conversion, like an automatic one set up. I do think it needs a WFR function for its own options, but I haven't written that yet.
Okay, fine.
But this is a slightly different scenario where there are not so many possible solutions.
So with fine molecule isomers, I could try and get that 413, or
I think it'd be good. I think it'd be very nice.
Okay.
Between find isomers and find molecule isomers, what do the more expert people think about that?
I'm not opposed to the longer one. Sorry.
Find molecule isomers would be less ambiguous, because as you mentioned, you get confused between nuclear isomers and chemical isomers.
Well, but should it then be find chemical isomers?
But it returns molecules.
Yeah, it's returning molecules.
Not chemicals.
Yeah.
I see.
Now I'm showing my ignorance here. I didn't know about nuclear isomers. So, you know, as a chemist, your side of the story is unusual to me.
Okay.
So it's hard to say what's the average user going to expect to know.
Right.
By keeping molecule in the name, it does align it with all the other molecule functions, which might help the user just reduce cognitive load.
Do we want to find molecule isomers, or do we consider it deterministic?
No, it
it's
does
not
need to be found, I
deterministic.
think.
Say that again. It's not. It's a shot in the dark, is what you're saying.
Depending on what's available in the resources in Pubchem or in the entities.
What would we make the default value for how many and the method?
Right. No. So I think that's a really good question, because to me, there is, and also like it's not clear that it should always return molecules, because sometimes it is useful, like in that example, to get the list of entities without first asking
I see
for
what you mean.
molecules and then calling toEntity on them. And so it's not clear. So to me, it seems like the second argument might tell you what you want, how you want.
So the second argument would be then string something like Pubchem, knowledge base, or something like algorithmic.
Maybe.
Well, hold on. So that details the method used rather than the return type.
Yeah, I think it's the return type we want.
But the method implies the return type.
Yeah, it really does. So if you're going to Pubchem,
They're not
then you can get
decoupled.
Pubchem external identifiers or molecules.
Exactly. We can't get entities for things that we don't have as entities.
Mm-hmm.
Right.
Okay, so it will be entity, molecule, Pubchem ID. Is that right? And I think that the way to deal with the, maybe there's a max items option, as there is web image search or something. Web image search, you're going to get potentially infinite number. And then, well, the problem is, look, I think it's got to be an argument because you really want the case of all. For some small molecules, you might want to say all.
Right.
That definitely would be the case in a classroom environment where you're working with, 10, 12 atoms and showing this off.
But even if it were an option, you could still say max items goes to all.
Yeah, you could. You could.
And we could make all the default.
No, that's
No.
But why not?
too dangerous.
Well, I mean,
look, why not make it?
dangerous if
It's
you
either
didn't
going to
have
be all. It's going to be up to. Basically, it's going to say up to. The default is going to be up to 10 or something.
Yeah.
okay.
Yeah.
Or it could be dependent on the molar mass of or atom count of the whatever you're inputting.
No, the number of iterations, for example, in phi minimum is a fixed number. It does not look at the problem.
Right.
I agree.
Yeah. Okay. All right.
Yeah.
All right. Find isomers probably is the right thing, given it isn't always returning a molecule, and this looks like a good thing to have.
So second argument would be entity or
Molecule,
and
probably as courtesy, allow the ones as non-strings, or Pubchem ID, if that's what we're calling the Pubchem ID, right?
Pubchem compound ID is what it's called in the external identifier. Yeah.
Okay.
Okay, well, so long as it auto-completes, people will be able to find that. And are there any other types of identifiers it might be?
Cas-Regnos might be reasonable.
So and so I would add more as I'm able to hook up the connections to the sources.
Ark is asking on live stream, can you show the spectrometer readout, presumably mass spectrometer from the chemical formula? How would you generate that?
No, you could. Yeah, you definitely could. I haven't. So let's see. So when I was in graduate school, one of the very few experimental things that I did was a TA for Pchem lab, and we looked at a mass spectra. So I think it involves looking at the isotope distribution.
Yeah, would it have to be for the molecular ion?
Mm-hmm.
And it also depends which mine. For these particular materials, it doesn't make any difference.
That too, whether it's crustal abundance or not.
Right.
So I do think that would be interesting.
Were they asking for the mass spectrum or the?
Well, they just said spectrometer, so I think they might
say
have
there's two. You can break it up and get the spectrum of all the different atoms that are in there, and then you can break apart the bonds and get different.
Just so I understand,
fragments.
we have the atomic. What do we have? What is it called?
Atomic
what is
level
the atomic?
You mean the spectra?
atomic line spectra.
Yeah, why isn't it? What is it
No,
called?
That's
no,
different.
no,
It's
it's
an
called
entity type,
differently.
right?
How
Is
is
it
it
spectral
called?
line data?
Yes,
Spectral line
yeah,
data.
yeah.
So there, if we'd say that, and then we say like carbon, for example, what are we going to get?
Carbon has a lot.
Okay, that's like the third ionized.
Yeah.
So how do I actually get the spectral lines?
Oh, look at the ref page. So you can say in this range, and
Why is it? Okay, okay. There's a lot of interesting stuff here. All right, let's not
Yeah.
get distracted. Okay. All right, so chemical formula. So from this,
further down there are some examples of getting isomers.
I see. But that says Pubchem isomers. Well, okay, that's just a method option.
Yeah, which we now changed. Now this would return IDs rather than molecules with the new design.
Yeah. I have a
And so-
question. I mean, how common is molecular mass, and should it just be a function as well as being this property?
No, so I would definitely make it a function, so that way
It's-
it could just
yeah.
eat a molecule, an atom. an
It's
element,
one of
an
the most
entity.
used things in alpha, what people ask.
Atomic
So why
mass?
don't we just have it be a function as well as being this property?
Yeah.
You just say
that's
molecular
good.
mass of percent.
Well, but there's 3 flavors of molecular mass.
So what? Well, what
Okay.
kinds?
Well, you
so
have the
then-
molecular mass in atomic units, you have the relative atomic mass, which has no units, and then you have the molar mass, which is grams per mole.
Another 2-argument function.
Yeah, there's a 2-argument function. What's the default?
Atomic. So I would.
This one
J-
here with
Jason
atomic
would say
mass.
I would think so, yeah.
Yeah, I agree. Yeah, the molecular mass.
So you could specify the units as an option.
Yes,
Okay.
not as an option, as a second argument.
Okay.
Are there any other things that are like super common? Is molar mass its own thing that's worth having a function out of?
Given that it's just a change of units from molecular mass, it seems overkill to have both.
Yeah, I agree.
There are calls on our live stream for all kinds of spectra, Raman spectra, IR spectra, and so on.
We're not there yet.
This is further down the road. This is further
We're
down
not
the
there
road.
yet.
So if we could go back to the find isomers,
Yep.
since we're coming up with the design right now. Let's see. So you could specify molecule, entity, or Pubchem, but by default, should I search in all of those places? Like, so let's say you say molecule.
Mm.
I could go to both sources or all sources when I start hooking up finding.
Well,
other
you seem to
places
have a
of-
way to represent molecules by Pubchem. What is this? Pubchem
so-
isomers. Are these all things which? Go ahead.
Right. So so you make a call to Pubchem and tell them the formula, and they spit back a list of IDs. And then in this particular case, I have to then go back to those IDs and filter
Okay,
out the ones.
so here's
that are
what I think you should do.
isotopologs and create
I think it should default to molecule. I think the default behavior should be just pick up things that we know about, so to speak. I think if we don't find any there, we go out and look at the Pubchem case.
Okay.
In other words, I think if we get, so the corner case is there are 7 an hour that we get in our knowledge base, right? But if we went to Pubchem, we would get another 4. Okay. Do we return 7 or do we wait and return 10? I think we return 7.
But at the moment, Pubchem is doing the heavy lifting, right? They're doing the search for us.
So if you look above, so in that example that's right in front of you, we have one entity with that
Okay.
formula.
Well, if you think we're going to need to use Pubchem in most cases, then that's what I would do. I mean, but I would sort the ones we have in front.
Okay, yeah, understood. And yeah, and molecule has the ability to hold meta information, so it can store the fact that it came from an entity or from Pubchem. If we
Is that obvious in the summary box that there's an entity for it?
no,
So the user would know that?
no, but I mean, so we have 2 entity that works on molecule.
Yeah, I
but
think
maybe
that
it's-
we should not put it in the summary box.
Okay.
Okay.
They look too non-uniform.
fine.
Yeah.
Fine.
But I mean, Stephen had suggested that they be upfront. So how is the user going to know? Is it the first 6 or the first 10 that
Doesn't
are
matter.
we have? Okay, fine.
I think it's just, let's give preference to those because, you
Yeah.
know, there was a reason why they're in our knowledge
Right.
base.
There are
That's
probably a
one way
little
to
bit more
rank it.
comments.
Yeah. Okay.
Okay, MQ on a live stream is mentioning machine learning of spectra. Yes, we've had multiple summer school projects on that subject. For these, commenting that engineers will expect grams per mole for molecular mass. I cannot comment on that.
Let's see. So actually, I mean, so there is an option. So the problem with the second argument is that you can't call set options on it. Whether that's a problem or
I don't think it's a big problem.
okay, because just there is an option that matches that, right? It's
You build your own current
target
forms.
units.
Yeah, you're right. You make your own curried form.
Right. Or you just have a function that does it. I'm sorry, what are the things, what's the option?
Target units.
Okay, well, fine. So if you set target units, it'll do the right thing, or you can explicitly use the second argument.
Okay, yeah.
All right, let's move on. Next item.
So next would be chemical reaction.
Slowly gets interesting.
Okay, do you think you have a representation for these things?
I mean, we're trying. So we kind of touched on this topic previously that that we have basically 2 different forms of a chemical reaction as a data structure. One that represents a reaction and it has stoichiometric coefficients and it can be balanced. You can take it an unbalanced one and you can balance it. And then we have a structural transformation, like a reaction that operates
which says this atom goes to here.
Yeah, and you need to have atom mapping between the reactants and products. You don't put coefficients in front of things. You don't balance it.
Why wouldn't you have coefficients? I mean, I see, because you have to. You know how amusing this is. You know, in terms of our discussion about this multi-computation paradigm, this is token deduplication. Whether those 2 water molecules are considered the same thing. In one case, they're not, right? If you're going to track which atom went where,
Right.
obviously those are 2 distinct water molecules. Otherwise, quantum mechanically, you expect the water molecules to be identical.
Right, and you just looked at this stuff before, and then you turned your head and looked back, and you have products, and you don't know which atom went to where. You can use your intuition to write that kind of stuff down, but for the purposes of this data structure, it doesn't matter.
And
Okay.
also, like this one, which we have in front of us, everything is totally explicit. There's nothing which has a dangling thing that doesn't matter.
I understand. So comment about this. We have this notion of entity. Oh gosh, what is it? When you have 3 baseballs or something, how is that represented in the entity framework?
Entity group on entity instance, you mean?
Yes. Which we haven't used very much. But this is a place where we could at least support that. Couldn't we? I mean, isn't that the right way to think about this? This is, 3 zinc hydroxide molecules. Seems like it's the same kind of thing as 3 baseballs.
Yeah, so...
But
so
it would a little bit limit us for things only that are entities. If we would have, say, a couple of explicit complicated molecules that we don't have, we don't
Well,
want
fine.
to
I'm not saying, okay, fine.
Okay.
So this is
So
probably the
are
preferred
you
form.
opposed to entity instance being wrapped around something that has head chemical formula or molecule?
It's a little bit abusive, but it's not obviously wrong.
Okay, good. So yeah, so we have a WFR right now that is for chemical conversions, and we're going to extend it to take entity instance.
Fine.
Kind of thing. So
What does it do? What is it? What?
convert 3 grams of benzene to milliliters. Or
I see.
Or a lot more complicated ones than that, but that's the basic.
Okay,
gist
so
of
it's similar to the Wolfram Alpha functionality for that.
Yes, we need it for Wayne because it's a very popular topic.
Okay. Well, and so one day we might want to design that as an in-language type thing.
Yeah.
Yes.
Okay.
That's the hope.
Look, this business about how, like, I mean, I'm wondering, sure, you can have this property, but, I just wonder if it's the thing that you're always doing, is this reaction balanced? Shouldn't there be reaction balanced Q, so to speak?
It
I
does
agree.
see a lot of use, so promoting it wouldn't hurt.
Okay.
It would be nice to have a separate function for it, yes.
Fine. Okay, but so now in terms of the representation reaction, this is the non-tracked token deduplicated version of this reaction. It has to be telling one something that the by the way, are there any other examples here or not yet?
No, not yet.
Okay, so what do you think it's going to look like when you're tracking atoms?
So so I wanted to know if you want to have a meeting to talk about that next week. And so I can send you, I'll paste it in chat. I have so we've been batting back and forth within the group.
We didn't think we would have enough time in this meeting to discuss the
All right,
more
okay.
complicated version.
Okay, but just give me a sense, because I'm trying to understand it as we try and design this one.
So so I just pasted a notebook
use the chat.
You would just use the functional groups for this, right? You just use the appendices and see if they would match. So you have some template. So you say, I have a little group there, and they react, and then I know that this is an ester or something. Could do something like this.
I have a feeling none of you were in the meeting about design for multi-computation.
I was.
I was there.
Oh, okay. Yesterday?
No.
No, not yesterday's.
Okay.
2 weeks
You
ago.
would have helped yesterday's. Okay. Basically, what that case is all about. You're taking an expression and here's what that involves. You take an expression, you rewrite sub-expressions, you glue the resulting thing back into the expression, which I think is very much the same kind of thing. Don't you have exactly the same issue with molecules? That is, you've got this big hunking molecule, and it's got this little piece that has a reaction. Or is that not what happens? Or
Right,
does
no,
it?
so
That's
we were,
more or less what happens. Yeah.
and so we've got two functions. I've
Okay, are you
template
pasting something in
reaction.
somewhere, because I don't see this?
Yeah, we put it.
I don't.
So
Oh,
in
you
the-
only, Jason, you only sent it to me.
Oh, I'm sorry.
So that's why I did see it. They say, why doesn't nobody look at it?
Sorry about that.
There it is.
Okay, so hold on. Okay, comment from Marco here. Please include a progress bar saying checking public databases.
Yes.
If-
No, so I'm using evaluate with progress for the.
Okay, fine. So it does do that.
And so here, yeah, I mean, so it's a big example, like the polymerization of amino acids, but it's the basic point that you have patterns going to other patterns, and you label the atoms with a mapping number.
Okay, this is so frigging analogous to what we're going to need for these. It's fascinating. Chemistry has been ahead of all of this stuff for millions of years, apparently.
First,
it has all the
right?
baggage. Well, no, it just has all the baggage of having actual molecules, as opposed to just idealized, symbolic expressions. Okay, but so what you're saying here.
Right, so you write a pattern that matches a substructure, and you mark the individual pieces of that substructure, and then you can refer to them on the other side of the arrow.
Yeah, I get it. But why are we not? I mean, we've got a whole system for this. It's called X blank. X is a named pattern variable. Why isn't this the same story?
So, okay, so if I did X and then colon and then an atom as a pattern on the left-hand side of the rule, and then I switched the rule to being a rule delayed, I wanted to write it like that. But sometimes you need to make specifications about that pattern when it appears on the other side. So on the left-hand side, it was atom, carbon, hydrogen count goes to 2, or formal charge goes to 1. And then on the right, it now has a different charge, and you need to specify that.
I
And
understand.
we'll delay
Why
complaint
isn't this
from
variable? Why aren't you doing it with, in this example here?
Mhm.
I would have said, so here, if it's the nitrogen thing, it's called, NN colon, and then that's the nitrogen thing. And then it could have a different atom NN hydrogen count on the other side. So long as atom has the right kind of idempotence, so to speak, that should work, as opposed to saying here, NN colon, which means it's the whole atom with that hydrogen count, if that made sense. In other words, this is representing the atom without hydrogens, presumably. And this is representing, the outside one is representing that atom with its ancillary hydrogens. And by the way, if you did it this way, we could also deal with bonds if you care about that. I don't know whether you do care about that.
Yes, we do.
We do, but normally, let's see. So it's only so you would change the bond between two mapped atoms.
Yeah, the bond pattern usually goes along with it when we write the molecule patterns for the reactants and the products. So
okay.
Yeah, I think we just have to play with some ideas here to see what we can do
I
about
strongly
writing it.
suggest that using the pattern matching scheme that we already have is the right thing. And arguably, one could have a full form of that C that, because I can imagine all kinds of stuff like saying, it can either be sulfur or fluorine or something somewhere.
Exactly. Chlorine versus bromine versus iodine. Yeah, that's very common. And also about the bonds, whether you care about the bonds or only that it's a ring.
Okay.
And so let's see. So let's see. So with that example right there, when you have a reaction with 20 mapped atoms, it would be
a nuisance to name everything.
To have to label them, or even just writing them out like this is a nuisance. But coming up with unique symbols for each.
Well, fine, but we can have all kinds of different ways to elide that. The question is what the default behavior is. Could even be that something notationally like this is supported, but it's just, what is the full form? How do we actually think about this?
Right.
And to me, yeah.
So to me, that C:6 is atom, carbon, comma, atom map number goes to 6. And I know that it does. We shouldn't let other languages dictate how we do things, but reactions, smiles, and smarts, and all of these things do have a notion of atom mapping. And so if we want to import them, then we need a way to represent that.
Yeah.
Look, it's also the case this is very reminiscent, and I suspect the same thing will come up. Okay, so were you to have a genome string, and you say, oh, I'm going to remove this, I'm going to delete this thing at that position. I have no idea what the notation then is for the coordinate system, if you get what I'm saying. Right, so there's a coordinate system on the genome, but clearly that canonical coordinate system doesn't include deleted elements. If you have a SNP, that's why SNPs tend to get labeled, RS, whatever it is, because there isn't, in fact, a coordinate system. And my point here is numbering things like this. Let's imagine you had a polymer of some kind, and you start removing pieces of it. Maybe nobody cares about this at this point in the history of chemistry, so to speak. But you get what I'm saying, that numbering is not, I don't know, maybe this is an irrelevant point. Maybe I'm just too concerned with what happens with strings and this multi-computation stuff with strings.
No, your point's well taken about numbering, and it is fragile. You discover after you've been working on it that you've left an atom out and you need to insert it in the middle, and half your numbers are wrong now, or something like that.
Well, it's like house numbering. In some countries, in the US, people tend to number houses with 0 zeros so that they can stick other ones in between.
Yeah.
Whereas in the UK, they number them sequentially, and then you end up with, 12B and things like this.
Yeah.
Yes.
But I think we should try using the built-in pattern expression patterns to see what we can do. I've been trying to write a number of these reactions for Jason as examples, and I've been sticking with the atom mapping numbering that comes from smarts and smirks because it's
so
just
this-
easier to get the input in, but I can try doing some with more traditional Wolfram language patterns and see what we can do.
See what happens.
It
Right.
supports them
Well, I mean,
both,
so
right?
however they work, like I'm going to have to write a parser for them,
Right.
and so
Well,
we
we'll
would-
talk about it, Jason. We'll see what we
Right,
can do.
but I also would like to point out that programmatically generating these things with colons will be very painful.
Mhm.
Yes.
So it seems to me, I've always thought I don't think there's any non-painful way of mapping the atoms, and that the best way to do it will be graphically, like with an interactive.
But how would you
Yeah.
even do it there? What are you doing? You're going to draw a line from one to the other?
I would have the reactants on the left, the products on the right, and I would click atom, and then as I click
but
more,
then
it
it's
would
got a
find
bunch of
substructures.
tentacles. It's got a bunch of threads going from one to the other. Is that right? Physially.
Something like that. I don't remember how they used to do it in the old Mac system, but they did support reactions in there, and I'm quite sure they entered them graphically.
So I
Right, but does it end up with some crazy color matching thing where the purple carbon is going to the purple carbon? Nobody can recognize colors. Or does it end up with a thread?
Well, back
So
in
I
those
didn't
days,
do
they
the
didn't have color.
So I didn't do the thread. What I have is mousing over, like, so when you mouse over an atom on the left side of the
Yeah, it
reaction,
flashes on the other side.
And you mark the ones that aren't done yet.
Blah.
right. So the
Blah.
version of reaction
Well,
plot that I have is definitely not going to be ready
Look,
for this.
as a test case, imagine a graph and imagine trying to mark off graph isomorphism that way. Which would be, I mean, like just imagine that you're doing an isomeric, no, actually, just imagine you were simply reconfiguring the same molecule. I assume there are molecules that do that can be in one shape or another. Yes, that does happen, doesn't it?
Mhm.
Yes.
Yes.
What's an example, just for my chemistry knowledge?
Bulvaline.
Which one?
Bulvaline. Let me type the spelling of it.
Yeah,
in chat.
bulvaline. Yeah, it rearranges cation rearrangements, and you can essentially scramble all the atoms and maintain the
Okay.
same bonding.
Lovely.
Are we
Okay.
talking about tautomerization, or is it more?
It's
Sigmatropic
cation.
rearrangements.
Mhm.
Sigmatropic, actually.
Yeah, 1-2 shifts or
Mm.
1-3
Okay.
shifts.
Okay. Ethan is asking about self-interactions in RNA strands. Wrong team to be talking about that.
You're working on that, so.
Okay. Not completely wrong team to be talking about that. Okay. Marco is commenting on external connections to spectrometer devices. I think we leave that to our friends at Emerald, who have been doing that very seriously. Are there chemical equilibrium and kinetics capabilities in the chemical reaction object? What does the chemical reaction object record about kinetics?
Right. So that is a future extension. So once we get the data structure in there, it takes a second argument with parameters, and you could specify a forward reaction rate and a backward reaction rate, those kinds of things. I mean, so
As
they
a
are
function of
tentative.
temperature and so on, presumably.
Enthalpy, everything else could be then stored there, yes.
I mean, the only reactions I know about are particle reactions, and one can imagine, pion proton scattering going to whatever, and it would work more or less the same way. And one would say, in that case, there's a cross section as a function of energy. I don't think chemists usually talk about cross sections, but you certainly could, right?
Mm-hmm.
Mm-hmm.
Oh, yeah. No, I mean, so yeah, no, reaction cross section is definitely a thing.
Okay, but then, I mean, these atoms that come, I mean, in particle physics, you would be worrying about the asymptotic states. And the question is, if you've got a zinc sulfate coming in, is every zinc sulfate like every other zinc sulfate? Is it considered that thing is just some sort of ground state object that's just sort of coming into the reaction, and then it goes into the, then it scatters in this reaction? Is that right? Or there has to,
it might matter if it's introduced as a solid or a liquid.
Oh my gosh.
It also depends on reaction conditions. If
That
light
too.
catalyzes it, it might be in an excited state.
Correct.
Temperature could change the vibrational properties, which also could facilitate a particular migration of bonds.
And isotopes can change it.
No, I understand that, but an isotope is not going to change. It's not going to transmute itself on in flight.
No, but if you put deuterated water into regular water, that the deuterated hydrogens are going to move around.
Yes.
Yes,
You'll get hydrogen exchange.
Yep.
So if I could just to answer that question from the live stream, having the chemical reaction here, the next steps would be functions like reaction thermodynamics and you wouldn't have a function called reaction kinetics. You would have some type of function that could monitor concentrations over time, and one of the things that it would need would be a list of reactions and then a list of things in your beaker. You could have a function called beaker, right, or petri dish, or
okay. I have to go to something and minus some number of minutes here. It looks like, as a matter of fact, my calendar has a gap for something that must have just dropped out. Do we want to continue this afternoon, or do we want to how much more do we have to do?
So that was all that I had for today, and with the idea that I would ask, would you have time to meet early next week to talk about template reactions?
I'd love to meet about template reactions, but I haven't a clue.
I can go work with the scheduler with you to figure that out.
Fine.
So the idea is that chemical reactions is more or less a container where you can do these stoichiometry, you can balance equations. You have something like this. And this is more or less a foot in the door for chemical reaction in 13, and then the template would be then in a later version.
Look, the thing I really want to think about, and I know it's kind of a heavy lifting type thing, is I really think this is so incredibly similar to these, transformations for this multi-computation business. And I just want to kind of think about what we can learn from the chemistry case for that and vice versa. But I don't, you should get a complete model for what to do with chemistry, and then we'll worry about how to move those two things next to each other, so to speak.
So in the meeting, so I assume you are fine with chemical reaction, the one that is absolutely explicit and no ambiguity.
This one, yes.
Yeah, in the meeting about template next week that Jason just mentioned, anybody else who should be there with respect to the Moody paradigm?
Ask again. I'm not sure.
Okay.
Not sure. It's not clear. I mean, maybe Carlo B. Not sure. Okay. And actually, what you've said about catalysts, both catalysts and okay. So
there's multiple cases you can have.
No, I mean, in my kind of amateur thinking about sort of the future of chemistry, so to speak, this whole business about actually tracking sort of, because most of what you're thinking about in chemical reactions is it has a certain temperature, it has whatever, it's not, that particular atom had this particular set of properties. Anyway, never mind, the different topic. All right, looking wonderful. Let's, to be continued early next week, I guess.
Thank you.
Okay.
Very nice.